As a member of steering committee of World Digestive Health Day, it is my pleasure to congratulate Professor S.P. Singh for organizing this meeting on the occasion of World Digestive Health Day. We all know that this year the theme for World Digestive Health Day is gut microbiota. Microorganisms that normally live in the digestive tract can perform a number of useful functions for their host, and we all know that more than 1000 different bacterial species are there in the human gut. And the combined microbial gene pool is estimated to be 100 times greater than the human genome. The major bacterial genera by phylogenetic analysis of 16S RNA gene sequencing show that bacteroids, Fussibacteria and Acinetobacteria are the major bacterial genera. Now, what function do they perform in the human host? They ferment the non-digestive dietary residue and endogenous mucus, which is a source for energy, and that's why we are realizing that altered gut microbiota can be a factor contributing to malnutrition, such as undernutrition in developing countries and overnutrition causing obesity in developed countries. They actually salvage the energy as short-chain fatty acids, which are produced by fermentation of unabsorbed carbohydrate in the colon. And in fact, we all know that these short-chain fatty acids such as butyrate, acetate helps in the absorption of water and iron from the colon, particularly the right side of the colon. They also produce vitamin K. They control epithelial cell proliferation and differentiation, and that's why alteration of these will lead to reduction of the trophic effect to the colonocyte, leading to diseases such as inflammatory bowel disease. They also protect the gut mucosa against the pathogenic bacteria or bad bacteria. Now, these gut microbiota is very, very important for maintenance of the health of an individual, and this can be altered, which is known as dysbiosis. So what is dysbiosis? We all know that the microbes in the gut have a gradient. When we go to the stomach, the number is low. When we go down to the ileum and the colon, number is high. So if there is a microorganism in excess in an abnormal location, such as we get a flora which is like colonic type flora in the jejunum, this is dysbiosis. Similarly, if we get a microorganism in excess number, for example, normally the jejunal aspirate grow less than 10 to the power 3 colony forming unit per ml in the jejunal aspirate. If there is overgrowth of bacteria in excess of 10 to the power 5 colony forming unit per ml in the jejunal aspirate, this is bacterial overgrowth. And microorganisms in altered quality, like the balance between the good bacteria and the bad bacteria is altered, and this is also known as dysbiosis. So dysbiosis means microorganisms in an abnormal location, in an abnormal quantity, or in an abnormal quality. Now, when the microorganisms are in abnormal quantity, such as more than 10 to the power 5 colony forming unit per ml of bacteria in the jejunal aspirate, this is called small intestinal bacterial overgrowth. And why do some people develop small intestinal bacterial overgrowth? This is because of reduction in the gut defense, which is contributed by salivary IgA, gastric acid, duodenal bile, aboral gastrointestinal motility, secretory IgA, Paneth cell and defensin, and normal ileocecal valve. Now what happens is that these bacterial overgrowth can contribute to several clinical conditions. For example, irritable bowel syndrome, particularly diarrheal type of irritable bowel syndrome, and potentially small intestinal bacterial post-infective irritable bowel syndrome. Malabsorption syndrome, inflammatory bowel disease like ulcerative colitis and Crohn's disease. In cirrhosis of liver, there is an excess of bacteria in the gut. This there to the extent of small intestinal bacterial overgrowth, which can contribute to hepatic encephalopathy, septicemia, and spontaneous bacterial peritonitis in this patient. Even intestinal tuberculosis, GI motility disorder, lactose intolerance can be associated with small intestinal bacterial overgrowth. Chronic pancreatitis can be associated with small intestinal bacterial overgrowth. We all know that this decade is the decade for a lot of research on functional bowel disease, because functional bowel disease understanding is going through a paradigm shift. Earlier we thought that this is all related to psychological issues, but we are realizing that this is not entirely related to psychological issues, but factors such as small intestinal bacterial overgrowth can contribute to irritable bowel syndrome, at least in a subset of patients. Now, why are we saying so? We know that gut flora in patients of IBS differ from that of healthy subject. In fact, there are several molecular studies on fecal microbiota in patients with IBS which show there is a qualitative change in the microbiota of this patient. Small intestinal bacterial overgrowth is reported in a subset of patients with IBS, particularly those with diarrhea. Symptoms of small intestinal bacterial overgrowth closely mimic those in irritable bowel syndrome. Constipation, which may be associated with bacterial production of methane, which reduces gut motility and serotonin, also throws a new light of understanding functional constipation. IBS can develop following acute GI infection, which is known as post-infectious IBS, and most importantly, manipulation of gut flora with antibiotic, probiotic, and recently fecal transplantation may relieve a lot of GI disorder, including functional bowel diseases such as IBS. Therefore, it is a high time that we focus our attention to gut microbiota. It is a very important organ in human body, and I actually thank World Digestive Health Day for taking this initiative to recognize gut microbiota as a topic this year. I also congratulate on behalf of World Digestive Health Day Steering Committee, Professor S.P. Singh, for taking this initiative, and I am sure that deliberation by expert in this meeting will enlighten all of us on role of gut microbiota in various GI diseases. Thank you so much.